Welcome to this explainer. We're diving straight into the James Webb Space Telescope today. But look, we're not just talking about a shiny new piece of tech here. We are literally talking about a time machine. I know, going back in time sounds totally sci-fi, but with this incredible instrument, it's actual reality. And we're not talking about rewinding a few centuries. We are looking back 13 billion years, right into the early universe. So let's just dive right in and see exactly how a telescope can act as a literal portal to the past. You know, during the launch, the broadcast perfectly captured the vibe. They said, lift off from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Just an epic quote, right? The universe kicked off with a Big Bang around 13.8 billion years ago, and this absolute marvel of engineering is built to look back a staggering 13 billion years. That means we get to see the cosmos exactly as it was just fractions of a billion years after it all started. It's nature's ultimate history book. Now, you might be wondering, how exactly is looking through a lens the same as traveling through time? Well, it all comes down to the physics of light speed. Light is incredibly fast, for sure, but space is just so unfathomably huge that it still takes time for light to get anywhere. Take our sun, for example. The light hitting your face right now took about 8 minutes to get here. If the sun just instantly vanished, we wouldn't even know it for 8 minutes. We're essentially living 8 minutes in the past. Now scale that way up. The galaxies James Webb is staring at are 13 billion light years away. So the light hitting those sensors today, it's been traveling through the void for 13 billion years. We are seeing those galaxies exactly as they were 13 billion years ago.
Actually, let's do a quick mind-bending thought experiment to really lock this in. Imagine you could instantly teleport to some planet 100 million light years away. If you set up a hyper-powerful telescope there and pointed it right back at Earth, what would you see? You wouldn't see cities or humans walking around today because the light bouncing off Earth right now takes 100 million years to reach that distant planet. You'd be watching dinosaurs roaming around. It's wild, right? When you look across these massive cosmic distances, you are literally watching history unfold.
So, to actually capture that ancient light, Webb has to rely on the invisible world of the electromagnetic spectrum, specifically infrared. Fun little side note here, infra is just Latin for below. So this is light operating right below the visible red light we can see with our own naked eyes. Because frequency and wavelength are inversely proportional, infrared waves are stretched out. They have much longer wavelength than visible light. But the really crucial takeaway here is this. Literally anything that radiates heat, whether that's you, a campfire, or a massive distant star, emits these invisible infrared waves. Okay, so how does this build our time machine? Like, why do we even need an infrared telescope to see the early universe in the first place? Well, it's all because of a phenomenon known as the redshift. Since our universe is constantly expanding, that ancient light has to travel across this continually stretching canvas. Over billions of years, the light's actual wavelength gets stretched and elongated right along with space itself. By the time it finally reaches our solar system, it's stretched so much that it's shifted completely out of the visible spectrum and landed right in the infrared. Without an infrared sensor, that ancient light is basically totally invisible to us.
And man, this perfectly illustrates the massive leap forward James Webb really is. We all know the Hubble Space Telescope, right? Legendary piece of tech. But Hubble primarily sees visible light, which is amazing, but it's kind of like trying to drive in heavy fog. In space, visible light gets blocked by these massive clouds of cosmic dust and gas. Because of that cosmic fog, Hubble could only peek back to about 1 billion years after the Big Bang. But Webb? Remember those longer infrared wavelengths? They just glide right through those dust clouds. It cuts completely through the fog, giving us these stunning HD views of the universe just 0.3 billion years after the Big Bang. It's revealing things Hubble literally never could. Now, to catch that super faint, ancient infrared light, you need a massive mirror. It's a basic rule of telescopes. Bigger mirror equals more light, which equals higher resolution. Webb features this absolutely massive honeycomb-shaped mirror array that just dwarfs Hubble's. But get this, the really fascinating part is what it's made of. The entire array is actually plated in real 24-karat gold. And no, that's not just NASA flexing its budget for the sake of it. Gold actually happens to be the ultimate reflector for red and infrared wavelengths. It bounces that ancient, invisible light perfectly right into the sensors. But of course, here is where we hit a massive engineering roadblock. Remember how we just said that anything generating heat emits infrared waves? Well, the James Webb Telescope is a machine. Machines generate heat. If the telescope gets warm, it's going to start glowing with its own infrared waves, which would completely wash out those faint signals from deep space. Basically, it would blind itself. To stop that from happening, the entire telescope has to operate in an extreme deep freeze. We are talking minus 223 degrees Celsius. To put that in perspective, the coldest temperature ever recorded on Earth hasn't even hit minus 90 degrees.
Now you might think, hey, it's space. Keeping things cold up there is easy. Space is freezing. Well, kind of. Space is very cold, but only if you're in the shade. The second sunlight hits you in a vacuum, the temperature spikes wildly. Take the moon, for instance. Because it doesn't have an atmosphere, on the dark, shaded side, temperatures plummet to minus 170 degrees Celsius. But step into direct sunlight, boom, it skyrockets to 120 degrees Celsius. If even a tiny sliver of direct sunlight hit Webb, it would bake the equipment and completely ruin its ability to see infrared. They literally had to find a way to block out the sun entirely. And their solution to this is nothing short of an engineering marvel. To protect all those delicate instruments, they deployed a kite-shaped sun shield roughly the size of a whole tennis court. It's built out of 5 layers of a specialized material called Captain. And get this, each layer is thinner than a single strand of human hair. They spaced them out with vacuum gaps for ultimate insulation, then coated them in aluminum and doped silicon. This ultra-delicate shield acts like the ultimate parasol, perfectly deflecting the sun's intense, destructive heat.
But here's the thing, the sun shield alone doesn't cut it. Location is everything. Hubble was parked in a pretty close orbit right around Earth. Webb, on the other hand, was sent a staggering 1.5 million kilometers away to this very specific spot known as the L2 Lagrange point. Why so incredibly far? Because the L2 point sits perfectly on the far side of the Earth relative to the sun. As the telescope orbits along with our planet, it constantly uses the Earth's shadow to hide from the glaring heat. It's exactly like putting your hand up to block the sun from your eyes so you can squint into the distance. But getting the telescope all the way out there and then successfully unfolding that massive tennis court-sized sun shield in the literal vacuum of space? Oh man, it was unbelievably stressful. NASA identified over 300 single points of failure during the deployment sequence. Let that sink in. 300! That means if just one single cable snapped or if one of those hair-thin layers tore, the whole mission was just over, kaput. The tension in mission control during those weeks was absolutely sky-high.
And the stakes literally could not have been higher because the final budget for this ultimate time machine was a mind-blowing $10 billion. This was a massive joint venture between NASA, the European Space Agency, and the Canadian Space Agency. It cost so much, in fact, that NASA actually had to completely defund several other research projects just to scrape together the cash to make James Webb happen. It was a massive, awe-inspiring gamble. But honestly, the payoff of finally unlocking the deepest secrets of the early universe makes it entirely worth it.
Which brings us right back to the future of this unbelievable instrument. We already know it's a flawless time machine, looking back at the literal birth of stars and galaxies. But those insanely powerful infrared sensors? They're also being pointed at modern exoplanets, analyzing the atmospheres of distant, alien worlds. Which leaves us with the ultimate question. Can it find a planet with Earth-like conditions? Could this very same telescope, the one looking way back at the birth of the universe, actually hold the key to our future by discovering a new home for humanity? I guess only time will tell. Thanks so much for joining me on this